The Curiosity rover is truly an interplanetary Swiss Army knife, equipped with a slew of onboard instruments for investigating the red planet.
The primary mission was 2 years, so we're into a couple extended missions now. Yeah, we don't know exactly how long it'll keep going. We never know, can't predict that. Things are still going great on the mission. We're discovering new rock units every day, so we hope for several more years to come.
The rover has been slowly meandering around Mars ever since it landed in 2012, using specialized instruments to examine the surface, perform experiments, and even find time to take a selfie. These instruments have led to some historic discoveries. In 2015, atmospheric readings from the rover suggested that Mars at one point experienced a vigorous loss of atmosphere, causing its ancient oceans to evaporate. And last year, Curiosity detected organic matter in sediment samples taken from Gale Crater. Since 2012, the rover has been traversing the 154-kilometer Gale Crater and has recently begun its ascent of Mount Sharp. Scientists want to know whether Gale Crater was once completely filled with sediment. Did it disappear over time due to erosion, or was the crater never filled at all?
Gale Crater that the rover is exploring in is 5 kilometers deep. Mount Sharp is a 5-kilometer tall mountain inside of that crater. One of the things that happens as you bury sediments on the Earth or any other planet is that you increasingly compact those sediments and lose the porosity, and those sediments will get denser and denser and denser as you bury them to greater depths.
The key to answering this question lies in gravimetry, the precise measurement of gravitational fields. These fields are correlated with density variations in the crust. Unfortunately, the rover wasn't equipped with instruments designed to detect these changes. To get around this, researchers recalibrated Curiosity's accelerometers, instruments normally used for navigation, to measure the changes in gravitational acceleration as the rover climbs the base of Mount Sharp.
You know, I kind of realized one day that gravity is just an acceleration, and we have accelerometers on board, and got kind of curious about how good those accelerometers were, and slowly began to figure out a calibration for that data to the point where we had a precision that was meaningful for understanding the geology at the landing site.
After 5 years of measurements, scientists were able to determine the density of Gale Crater's sedimentary rocks.
Well, in this case, one of the interesting things is that the density was surprisingly low, even for sedimentary rocks, which tend to be lower density than, say, a lava, right? The surprisingly low density tells us that these sediments were likely never buried to the full depth of Gale Crater, which would be 5 kilometers.
As the mission rolls on, researchers would like to use Curiosity's accelerometers for another purpose, to measure Mars's seismic signals in the hopes of detecting a Marsquake.
What we kind of show is that they're not great seismometers, so we would need either a pretty large earthquake or a pretty nearby earthquake to detect it, at least in the measurements that we're currently making.
And while it's unlikely that Curiosity will detect a Marsquake, the InSight lander is designed to do just that. Researchers would also like to solve the mystery of how Mount Sharp came to be.
Yeah, so Mount Sharp kind of continues to be a puzzle. We don't know, especially for the upper layers of the mountain, how that formed. The whole thing is a stack of layers, and the layers are all tilted outwards. So it's almost like a haystack in the middle of this 5-kilometer deep crater. So especially for those upper units, they may have kind of formed as a freestanding haystack rather than having filled the crater entirely. But that's just a theory, so we'll have to get up there and figure it out.